For mini challenge 2, we built up a visualization system called MetaCurve, meaning the curve of multiple curves. MetaCurve aims to help with interpreting and analyzing a large number of time serial measurements. Aggregating periodical data, MetaCurve reveals daily patterns by showing possibility ranges and outliers of the data. The Overview tab shows the relationship between proximity zones and HVAC zones. User can see the corresponding area in the map by mouse over the links connecting zone names. This dataset contains many one-day cycle periodical data. Using statistical interquartile measurement, we computed outliers at a given time across different days. The Outlier Overview provides a summary of daily outliers, clockwise from day 1 to day 14. The radius of arcs shows the number of outliers of that day. Using K-means clustering algorithm, data with similar daily patterns of outliers are grouped. Clicking on one cluster will show all the curves in the group. The scattering outlier marks are added up to create a pie chart showing the total outliers count of 14 days. More outlier during a day, the greater radius it is. Building sensor data are periodical. We plot and overlay the 14-day raw data day by day using one-day span. For sensor data with continuous value, an interquartile range measurement deviated from the median of the data are being used to identify outliers. The area curve graphs show the possibilities of a measurement at a given time. The darker area shows the normal data range that have a big chance, while lighter area shows the data value at a minor chance. Major outliers with the value that more than 3 interquartile range are marked with dots. Outliers from different days are marked by different colors and borders. Some measurements have discrete values with 0, 1, or at a certain interval. We use a multiple band line graph to show the possibilities of the measurement at a certain value at one same time in different days. A similar strategy is being adopted to plot the ranges of the population change in each proximity zone and individual employees' activity. The related data is also periodical, so we divide the time intervals into 5 minutes. The population in different zones are shown as different curves as what we did with the building sensor data. The line graph shows the employees' activities. An employee is at a zone at a given time in most of the days. The area is in a dark shade. Light shaded area shows minor outlier that only 2 to 3 days the employee stay at the zone. If the employee only stay at the zone for once, it will be marked as a dot, namely a major outlier. The data of the same employee using 2 different proximity cars are combined. The graph can easily show if 2 proximity cars belong to the same employee are being used at the same time. With the Sankey diagram showing the relationship between proximity zone and HVAC zone, we are able to connect employees' activity patterns with HVAC sensor data. Examining all sensors data in one HVAC zone and checking the population in related proximity zones, we are able to see how employees' activity affect the HVAC performance. Typically, we cross-reference the similarly designed area curve graphs of building sensor data and population in proximity zones. For example, for the daily on the first floor, which is in HVAC zone 1 as well as in proximity zone 2, the zone population, thermostat temperature, and the CO2 concentration reach a peak during lunchtime. The green line is 14-day median. We can also notice the 3 peaks have chronological order. First, the personnel enter the zone and then the temperature rises due to activities, and finally they result in the rising of CO2 concentration.